Welcome to R1 rational functions. So in this video, we are going to try to make the best efforts to how to try to find our x-intercepts, right? And so before we do that, maybe let's look at a basic equation, kind of start with the very basics. Let's say we just have something very simple, something like, let's say we have y is equal to 2x plus 8, okay? Now, you should also note that I got a new Wacom tablet, which means it's going to be pretty nice. It should look a lot better when I'm writing now than in my other videos. All right, so let's say we want to find our x-intercepts. Well, if we look on the graph, our x-intercepts occur when our y value is 0. Well, we can see that it's right there. It happens to be at -4. So we know that our y value should be 0. So if we set our y value equal to 0, we get 0 equals 2x plus 8. We subtract 8 to both sides. And when we subtract 8 to both sides, we're going to get -8 is equal to 2x. Then we just divide by 2, and you see that we get our x-intercepts to be -4, exactly what we had previously on the video. All right. So what if we have something a little more complicated? Let's say we go to something that looks a little bit like that. All right. Now the equation for this is going to be y equals x plus 3. We're going to get x minus 2 all divided by x plus 2. Okay, well now what if we want to find the x-intercepts for a function like this? Well, we know our x-intercepts is right here. It happens to be at -3, and we have an x-intercept right there, which happens to be at 2, right? Just 2. So, well, like before, if we want to find our x-intercepts of this rational function, right, now we have this basically a polynomial equation on top divided by another polynomial equation. We want to find the x-intercepts. Well, the basic principle is the same, right? Our y value is still 0. So we set it equal to 0, and we're going to get x plus 3, x minus 2, oops, all divided by, let's just clear that up. That looked kind of weird. Okay, let's go x minus 2. All right, all divided by, just still getting used to this weird little tablet, x plus 2. All right, so now what do? Well, we want to solve for this function. Well, I mean, just like before, you know, we have 0 over here. So the first thing we want to do is we want to eliminate, right, this x plus 2 from the bottom. So we multiply x plus 2 to both sides. Multiply x plus 2 to both sides, and you'll notice, right, x plus 2 and x plus 2 here are going to cancel out, and this right here, x plus 2 times 0, well, that's just still going to be 0. Anything times 0 is 0, so we're going to get 0 equals x plus 3 and x minus 2. Okay, well, now, all we need to do is just solve for it like we have in the past. We're going to get 0 equals x plus 3. We set these up individually and solve for them. And, you might be able to do this in your head, but we'll just do it step by step. And we get that x is equal to -3. Then we go over here and we have to add 2 to both sides. And we're going to get that x is equal to 2. There you go. So you can see just like it matched on the graph right over here. Right here we got -3 and 2. All right. So let's go ahead and look at another example here. Let's say we have y is equal to x plus 5, x squared plus 12x plus 20, all divided by x squared plus 2x plus 1. All right, so if we look here, this looks a little bit more complicated than some of the functions that we've worked with in the past. All right, but if we want to find the x-intercepts of these functions, right, we need to set our y value equal to 0. All right, so if we set our y value equal to 0, we're going to get 0 equals, we're going to get x plus 5, and then we're going to get x squared plus 12x plus 20, all divided by Well, x to the third plus 2x plus 1. Again, you can see that no matter what, if I multiply x to the third plus 2x plus 1 to both sides, okay, these are going to cancel out. And again, 0 multiplied by anything is still 0. So you can kind of see when we're finding our x-intercepts, we can ignore the denominator because we're always going to multiply it by 0. And so all we're going to do is just focus on the top, right? And we say each one of these individually equal to 0. But before we do that, let me just go ahead and write it down. X squared plus 12x plus 20. Okay, so here we're going to get 0 is equal to x plus 5. And over here we're going to get 0 is equal to x squared plus 12x plus 20, right? I'm sending each individual factors to 0 and trying to solve. So over here, all we got to do is subtract by 5 to both sides. And we're going to get that x equals -5. All right. Now we want to go ahead and solve for this, right? Now we could use the quadratic formula, but before we use the quadratic formula, I recommend factoring. I recommend trying to factor, right? So we go over here. Let's write all the factors of 20. 1, 20, 2, 10, and 4 and 5. Okay. Now, is there anything that I could do with 1 and 20 when we add or subtract them to get 12? Well, we can't do anything with that. Well, how about 2 and 5? Well, I know I can do 2 plus 10 gives me 12. And 2 times 10 gives me 20. So I'll go ahead and write this as x plus 2, x plus 10. All right, now over here, like we've done before, I'll just set these all individually to 0. So now we subtract 2 to both sides, and we get x is equal to -2. Subtract 10 to both sides, and we get x is equal to -10. And there we go. Therefore, my three x-intercepts are -5, -2, and -10 for my original function, right? And I should feel pretty confident about that. All right, let's go ahead and maybe look at another example. Let's say we have y is equal to x squared minus 4, x plus 2, all divided by x, x plus 1, x minus 10, and x minus 6. All right, so let's go ahead and look at something like this, right? We want to find the x, identify, right? We want to identify the x-intercepts, all right? Or some people call them zeros, okay? The x-intercepts, zeros, or the roots, whatever. They all mean the same thing, all right? So we want to identify, like before, all right? Hopefully you could tell, right? We can ignore the bottom part, right? We can pretty much ignore this, all right? And we're just basically going to focus on the numerator. So 0 is equal to x squared minus 4 and x plus 2. Now, again, we just set these individually into two different factors, set them equal to 0, and we just solve. So we subtract 2 to both sides. X is equal to -2. Over here, I'm going to have to add 4 to both sides. And I'm going to get 4 is equal to x squared. Then I just take the square root of x. And we're going to get x is equal to, don't forget the plus or minus, all right, plus or minus 2. So you'll be able to tell that our x-intercepts are x equals 2, x equals, this is from over here, from the +2, then the -2, and x equals -2. So our x-intercepts are these right here. And we could expect that at this location right here, since we both get a -2, -2, this is a double root, which means it's going to make a U shape, probably right there at -2, or maybe it's upside down like that. But either way, we should get a U shape. It's a double root because it occurs twice. All right, so there we go. All right, and I mean, if we really want to, we can always go over even another example if you want to, just to get a bunch of variety of different styles of problems. Right? Let's look at something like this right here. Again, let's just ignore the denominator because we're always going to multiply it by 0, and we're going to get this right here. Okay. Well, you can see here that this x is just x by itself, so we just set them equal to 0. X equals 0 because there's nothing for us to subtract or add, right? When we set it equal to 0, it's just x equals 0. And over here, we're going to get 0 equals x plus 3. So over here, we just subtract 3 to both sides. And we're going to get that x is equal to negative 3. And over here, we just get x equals 0. So you can see that whenever you just see an x there, right, this is just the same thing as 0 equals x plus 0 and x plus 3. And the x plus 0 is just x, right? So when we set it equal to 0, it's just x equals 0. All right. Hopefully that helps you find the x-intercept.